Hello everyone. This is the place where we left off last time. So we were speaking about this kind of curves like this ellipse and how we can make a mesh out of it in order to make it as an input for our Kangaroo Solver. So instead of using this mesh surface in this kind of problems, we need to change it to mesh Brep, which is in here in the mesh utility. And if you connect this surface to the Brep input, and you can have this kind of mesh, but as you see it's a little strange, so we can just set it by changing these settings. And you can go to this utility and these settings in here, you can connect it, and as you see it has changed this mesh, but you can also change it more with getting some numbers to these values, the minimum number and maximum number of the quads. Let's say the minimum would be 4 and the maximum on 8. No change yet, but in here we have a minimum length for edge and maximum. So the minimum, let's say on 4, and the maybe also add to this number to see how it's different. Also, if we change this number, we can see that it has changed the mesh. Okay, this is one mesh that it has made, and if we use it as the input, let's see what we will have as a result. Or we can change the supports, because we made some kind of manually changing these naked points, which now we just want to use this the whole numbers as we have it in the naked vertices component, as we told in the previous video. So as you see, if I just hide these parts and add to this number, we can see that it makes a inflated structure, and we can add to this number to have it more becoming more up, and also changing this number can result in having different outputs. But this is some mesh that it has made using this component, and now we can change our mesh. We can remesh this mesh using Remesh, and one of them is Remesh, quad remesh, and also we can have a TriRemesh. So let's consider both of them. Quad remesh, and if I connect this mesh to this one, now we can see that it's completely different from what we had. And if I connect, let's see what parameters it has. It asks for grids, guide curves, and also for the settings, so we can use the same setting in here. Oh no, that's different. We should use Remesh setting. This is quad remesh setting, and we can also find it inside the mesh in here, quad remesh settings. And if I connect it, I can change the numbers The first one is the target count, which is now on 1000, and we can reduce it to something like 200. As you see, it makes fewer mesh faces. And now let's use this new mesh as our start point and work with this. So I can lock a screen just to make everything work and then run it. So I'm connecting everything that was connected to this mesh to this remeshed, and now let's see what we have. Okay, let's hide things in here and also hide here, and we can work with these numbers. Okay, as you see now, we have all the naked points as our supports, and also we can work with these numbers to change our mesh. Also, like what we discussed in previous video, we can change the support points, we can make it less, and that's it. Also, we can change this number in here. Let's see. As you see how we increase, as we increase this number, our final mesh is more smooth compared to when it's something like 50. And also we can remesh it to a triangular shape. We can use this one, or we can also use the Triangulate. So I can add the output of this mesh and let's put it on false. And so I can use this Triangulate, but it's not what we really want it to be. But if I connect the output of this quad mesh to this Triangulate, this is more suitable. And if I connect this one to the inputs for the Kangaroo Solver, we can see the difference. Okay, now we can see that if we have a triangular mesh, it makes this kind of final form. Let's bake it. And if we connect just this quad, so by pressing the Ctrl and Shift, you can have all you had to this input, to this output, connecting to this another output. And with the same numbers, you can see that with a quad we have a more deformed structure compared to what we had for the triangular mesh. Okay, but the difference of using this Remesh Triangulate with this one is that this TriRemesh, which is also in the triangulation part of the mesh tab, this works so that the triangles are more likely equilateral, so that's the difference. And if I connect this geometry, and let's false this component and hide it, you can see that it's now different. It's more like a equilateral triangular mesh, and this is the output, remesh the result. And now let's connect everything to this output and unhide our result and make it true. So this is much more smooth than what we had in the first mesh. And also, as you see, the deformation with the same numbers for the load, for the strengths of our anchors, and for the strengths of our mesh edge lengths. This is more deformed than this another mesh. Both of them are triangular, but the edge lengths for each triangle, it's in here is something similar to the others, but in here they're different. You can also change these inputs, like this length of the mesh edges. It's now on empty, but let's put it on 4. Or bigger. Let's put it on 12, maybe. Okay, you can see the difference. And I can add it. It's becoming more similar to this one in the case of mesh edge lengths. That's the end of this video. I hope you found it helpful. Please like the video and subscribe for more videos like this.